Hi, I'm Peter Adamson, and you're listening to the History of Philosophy podcast, brought to you with the support of the Philosophy Department at King's College London and the LMU in Munich, online at historyofphilosophy.net. Today's episode, The Acid Test, Theories of Matter. Is a human body more like a cake or more like fruit salad? You might say like a cake because its arrival means that it's somebody's birthday. But what I mean is something else. I'm asking about the human's material composition. If your body is like a cake, then the stuff that was used to make you has been replaced with a new substance. Just as there are no actual eggs in the finished cake, the initial ingredients of your body are no longer actually present in your body. This would be the view of Thomas Aquinas, who held that each substance has only one form. For him, a human body is made ultimately of the four elements, and even they have a material substrate, namely formless prime matter. But the elements and higher-level ingredients, like blood or bone, have been taken up into the compound of form and matter that is the body. All this stuff has literally been transformed, rendered from earth or blood into something new by receiving the form of humanity. If, by contrast, the human body is like a fruit salad, then it consists of parts that remain the same as they were before they were combined to make the body, parts that will also retain their natures once the body is destroyed. You can also take parts out of the body without necessarily destroying it, by drawing blood, for instance, or pulling a tooth. This is like removing the bits of banana that someone unaccountably thought would be nice to include in the fruit salad, forgetting that they always get mushy. If this is your view, then you think that the substances we see being generated and destroyed, as when people are born and die, are made up of corpuscles, meaning small bodies. And in the unlikely event that you live in the 16th or 17th century, if you believe in corpuscles, then you are probably an atomist, meaning that for you, the human body, and indeed every physical object, is an aggregate of indivisible particles. But you don't actually need to believe that the parts are literally atoms, that is, uncuttables, which is what the Greek atoma means, as I mentioned 380 episodes ago when covering the ancient atomists Democritus and Leucippus. Maybe the corpuscles are in principle divisible, maybe they aren't. Sometimes scientists of this period casually referred to things as atoms just to mean that they couldn't be divided through any known laboratory technique. They might even be visible, as in a vapor cloud that is made of tiny droplets, or metal that has been turned into a pile of so-called atomic powder. The real point is that they are actually present in the substance, all jumbled together to constitute, in the case of the human, blood, bone, and ultimately the whole body. To find out whether a substance is like cake or like fruit salad, a good test would be whether you can decompose the substance into the same ingredients you used to make it in the first place. As the scholastics like to say, in quae dissolvi possunt composita ex iisdem colaurunt. The things into which composites can be dissolved are the things out of which they are made. You can turn eggs, butter, and flour into cake, but you cannot get the eggs, butter, and flour back out of the cake. Whereas you could carefully turn the fruit salad back into the chunks of apple, grapes, and melon that you started with. And yes, we have no bananas. That contrast might suggest that some substances contain actual corpuscles and some not, in which case we will have to answer our question on a case-by-case basis. But someone like Aquinas would say that any genuine substance is unified by its form and has no actually present ingredients in it. Of course, he would not think fruit salad is such a substance. His preferred examples would be organic bodies, plants, animals, and humans. A corpuscularian, by contrast, would say that even organic bodies are made of other, far smaller bodies. Every significantly sized body around us is nothing but a mixture or aggregate of parts. Even cake. It is like fruit salad after all. It's just that its tiny parts, which persist through the process of making the cake or digesting it, must be sought at the chemical level, not at the level of eggs and butter. It was, in fact, chemistry that provided some of the strongest empirical evidence in favor of corpuscularianism around the turn of the 17th century. At about this time, powerful acids were discovered, like sulfuric, hydrochloric, and nitric acid. This made it possible to dissolve substances much more quickly and thoroughly than before. Scholars interested in chemistry or alchemy, remember at this time these were effectively a single scientific discipline, noticed that they could dissolve a metal, like silver, in acid. Then, using alkalis, they could get the silver to precipitate back out of the fluid in the form of particles, like a powder. This acid test seemed to provide dramatic proof of corpuscles. The dissolved silver is not visible in the fluid, yet must still be present. How else would it be possible to get it back? It must therefore be in the fluid as particles that are too small to see. The philosopher Daniel Sennert described this experiment in a work called On Chemicals. On the basis of this and similar evidence, he concluded that the ancient atomists had been right, and Aristotle and his followers, like Aquinas, wrong. The generation of a substance is not the acquiring of a substantial form by a material substrate that has a potential for that form. It is just an appropriate combining of atomic parts. Likewise, destruction is nothing but the separation of those parts. The atoms themselves endure through the whole process, something he illustrated with the example of a goat eating a medicinal plant, a nursemaid drinking the goat's milk, and passing on the plant's beneficial effects to the infant she is nursing. Those effects are thanks to the corpuscles that were in the plant, were still present in the goat's milk, and were then passed on to the maid's breast milk. Now, this discussion from Sennert comes from 1619, a bit later than the 16th century, which has been our focus in the current series of episodes. But his atomic theory is a natural outgrowth of the ideas we talked about last time when discussing Paracelsus. For Paracelsus, the fundamental constituents of things were sulfur, mercury, and salt, which are actually present in more complex bodies, as we can see from the fact that they can cause diseases in those bodies. This is why one of his critics, Thomas Erastus, tried to refute him by saying that on the Paracelsan view, it should be just as possible to turn vinegar into wine as it is to let wine turn into vinegar, and that there must already be worms present in fresh cheese and meat, since worms appear in these foods when they rot. So maybe we should just stick to cake and fruit salad. This was in 1572, showing that the corpuscularian theory of matter was worming its way into philosophical debates well before the 17th century, when it would be prominently adopted by such famous thinkers as Descartes. Now, I should admit that, in fact, these two positions, which I have presented as being diametrically opposed, could share something in common. To keep things simple, I contrasted corpuscularianism to the view of someone like Aquinas, for whom there is just one form in each genuine substance. But actually, that single form view was already a minority one when he put it forth back in the 13th century, and it is not what Erastus was trying to defend. Rather, Erastus accepted what is sometimes called form pluralism, according to which there may be several substantial forms actually present in a single substance. In addition to my human form, for example, I have the form of body. Not the human body, that is, but just the form that belongs to whatever is extended in three-dimensional space. When I die, the form of humanity will be lost, but the form of body will not be, since my corpse will still be an extended body. Nonetheless, Erastus's view is hylomorphic, meaning that each substance, whether body, human, cake, or silver, is a composite of matter and form, with matter providing the potentiality and form the actual determination of that potential. As for Sennert, while he rejected the analysis of substance into matter and form, he also thought in terms of multiple levels of physical composition. A bar of gold is made of gold corpuscles, but gold is not a fundamental element. Rather, its parts are made of even more basic particles. Like Paracelsus, Sennert assumes that the ultimate chemical constituents are sulfur, mercury, and salt, which come together to form more complex materials that derive from them. Furthermore, neither Sennert nor Paracelsus tried to explain the observable properties of things by appealing to the physical properties of atoms. This is a significant difference from ancient atomism. Democritus said that the soul must be made of very smooth, round atoms that can flow around the human body, while Plato, in his Timaeus, proposed that fire destroys things because it is made of tiny particles that are sharp because they have the shape of pyramids. Instead, late 16th and 17th century corpuscularianism generally ascribed certain powers and properties to each atomic aggregate, like the healing effect of a drug or the corrosive effect of acid, without reducing these features to the mere physical shapes of the corpuscles. For this reason, the sort of atomism we see in Sennert and others has been seen as a kind of compromise between the true physical account of classical atomism and a form or property based physics like that of Aristotle. In his book on the chemistry of this period, William R. Newman even says that Sennert's view was a fusion between Aristotelianism and alchemy. But Sennert himself was something of an expert on fusion, and he would have disagreed. He saw himself as being in agreement with Democritus, and indeed a general tendency in ancient philosophy, one that had been interrupted by Aristotle's idiosyncratic, though ultimately more influential, physics. Atomism had been the view, said Sennert, of virtually all the ancients before Aristotle, and even many after Aristotle. And there was another ancient idea taking renewed root at this time, the theory of seeds. We saw how Paracelsus believed that natural things emerge from basic elemental ingredients because God placed the seeds of things in those ingredients at the first creation. This sounds a good deal like the Stoic theory that nature implants the rational principles of things, or logoi, in matter as seeds. It's an idea that would have been known to Renaissance readers, thanks to Augustine, and also Cicero's presentations of Stoic doctrine in the Latin language. During the 16th century, one proponent of the seed theory was Jakob Schegk, who studied in Tübingen and was appointed there as a lecturer in philosophy, following the reform of the teaching curriculum by Melanchthon. In a treatise written in 1580, Schegk argued that when plants, animals, and humans are generated, this occurs thanks to a formative or plastic power seated within matter. For him, this is the meaning of Aristotle's appeals to the role of vital heat in the formation of animal embryos. Like Paracelsus's seeds, Schegk's active power within matter has been put there by God. Once the plastic power has done its work in forming the fetus, the organism's soul replaces it and fully animates the body. These ideas, too, were inspirational for Sennert, who used them to explain the supposed phenomenon of spontaneous generation. Those worms crawling out of the moldy bread and cheese come from something analogous to seeds within matter, as he puts it. And even metals, as Paracelsus had claimed, emerge thanks to the power seated within matter. The species of gold, silver, or copper are propagated by such a power, much like an animal species. Sennert did modify Schegk's account to some extent, though. Seeking to give the soul a greater role in both natural and spontaneous reproduction, he proposed that the soul must lie hidden within the corpuscles that come together to form the organic body. So again, Sennert's atomism, or corpuscularianism, is not mechanistic. The particles of matter have powers and properties that are reminiscent of Aristotelian forms, and Sennert believes that soul is latent or dormant in them, expressing itself when the time and circumstance are right. Schegk had a connection to another early proponent of the fruit salad theory of bodies, Nicolaus Taurellus. He was a student of Schegk, and along with him defended the view that substances are aggregates of parts, with higher-level forms emerging from lower ones. Taurellus also invoked the rule of composition that motivated so many corpuscularian views. If things were born through the conjunction of parts, they decay through the separation of the same parts. Like other atomists, he denies the reality of prime matter, the featureless substrate that was supposed to underlie the four basic elements. More surprisingly, Taurellus talks as if the atoms of his own theory do not count as matter at all. Matter, he says, plainly does not exist, and nothing but forms can be and can enter composition. Mixture or composition, meanwhile, is a mere conjunction of forms that in no way changes them. Against the notion that we need some kind of matter to explain why bodies are extended in space, he proposes a breathtaking thought experiment. Imagine a universe with only one element, like a whole cosmos made of Earth. In that universe, it seems obvious that spatial extension would simply be a property of Earth. In our more diverse universe, then, it can belong to all bodies, or at least all fundamental bodies, by virtue of their forms. Here, then, we have something like traditional form pluralism, but without any commitment to matter supporting the forms. Higher-level forms, like the form of humanity, supervene on lower-level ones, like the form of blood and bone, which in turn belong to forms like those of the elements. And blood and bone, or earth and water, are explained atomistically. The particles touch without merging into an undivided continuum. So, much as Sennert would later do, Taurellus combines something like a Democritean physical theory with something like an Aristotelian theory of natures and properties. Taking our story forward to the early 17th century again, there is one more philosopher we should consider, David Gorlaeus. Honored as the Dutch Galileo for his innovative physical theories, Gorlaeus lived to be only 21 years old, dying in 1612. Fortunately, he was precocious. Two works of his, both published posthumously, followed Taurellus in holding that even the human being is a single substance by aggregation, not by essence. The soul has been added to the body and penetrates through its atomic structure. This is something we'll see again when we look at Descartes and other 17th century dualists. Since they thought that the soul and the body are different types of metaphysical entity, they were often more attracted by atomism than Aristotelianism. Better to say that the human body is a mere accumulation of corpuscles with a properly separate soul to rule over it than Aristotle's idea that soul is the form of the body. Indeed, Gorlaeus explicitly rejects the hylomorphic account of substances inherited from Aristotle. Bodies are only aggregates of particles, not matter actualized and organized by form. To illustrate, Gorlaeus mentions the familiar examples of a cloud of water vapor or pile of stones. Apparently, fruit salad was not yet widely available in the Netherlands at this time, though you'd think it might have been popularized by William of Orange. For Gorlaeus, the fundamental elements are not the chemical triad accepted by Paracelsus and Sennert, but water and earth. Fire is explained away as mere heat, generated by friction between particles, while air is a non-elemental fluid filling up the gaps between and inside atomic aggregates. Notice that Gorlaeus does not accept the reality of void, another departure from the classical atomists. For Democritus or Epicurus, matter consisted of atoms moving around in empty space, not in a fluid substance like air. So that is a point of agreement between Gorlaeus and the Aristotelians. Furthermore, like the other atomists we've been talking about, Gorlaeus thinks that properties, including heat and cold, can belong to an aggregate as a whole. So yet again, this is more like a property in scholastic philosophy than what you have in classical atomism, where perceptible features are explained reductively by appealing to the shape, speed, location, and entangling of atoms. The Aristotelian worldview was dissolving, but not with the sudden fury of a body thrust into pure sulfuric acid. Scientists around the turn of the 17th century preferred to offer more moderate solutions. In the previous episode, I suggested that the new chemistry and medicine of Paracelsus might be explained by the times in which he lived, a reformation of science in parallel to the religious reformation going on just down the road. Literally so, in his case, he had to flee from Salzburg when the Peasants' War broke out there. The topic of today's episode may seem so abstract and purely scientific that it cannot be connected to the religious disputes of the age, but it turns out that there may be a way to do just that. It's been argued in modern scholarship that Gorlaeus' theory of matter was partially inspired by Arminianism, a variety of Protestant thought that had gained a foothold in the Netherlands by his time. I'll explain why once I've taken you through the spread of Protestantism to the Low Countries and the impact it had on philosophy in that region. Next time, we'll continue our investigation of divisibility by splitting the Schegk, because we're going Dutch here on the history of philosophy, without any gaps.